Good afternoon, everybody. And I'm Mira, and we are going to introduce the Rotterdam Smart Port solutions to digital transformation technology problems. And Lily is my partner, and we will show you the report. And our content is divided to 3 sections. In the first section, I will introduce the current status of Rotterdam Port. And the second section, we will analyze of the cause and some problem in digital transformation. And the last section, Lily will analyze the review of Rotterdam Port's current smart port policy and their effectiveness. So I'm going to introduce the first part, the current status. A Port of Rotterdam building a digital material model, and it can divide it to 4 levels. And the level 1 is digitization of individual parties in the port. And when they move to level 2, they will integrate the systems in a port community. And level 3, they will extend their logistic chains to hinterland. And finally, in the level 4, they will connect ports in the global logistic chain. And let's talk about each level. Level 1 is about the individual parties in the port. And in this level, they use 2 main systems. The first one is PMS, which is Port Management System. And it can let the port procedure more faster and cheaper. And PMS can manage the berthing time and financial process. Also can improve loading and unloading efficiency and reduce turnaround time. The second system is AIS, Automatic Identify System. It combined with sensor inside the port. For example, Rotterdam collecting information like shipping routes and sediment in the port basin, and it that the procedure can reduce dredging cost by about 5 to 10%. I move to level 2. Level 2 is about integrated system in a port community. And in this level, the Port Authority says the security is the top priority. And the Port Authority in this level acts as a neutral platform and use some data exchange system to support B2G and B2B communication. And in fact, Port of Rotterdam was established PCS named Port Bas with Amsterdam, and through this PCS it can reduce communication cost, data cost, and transportation cost. With level 3, they want to extend the logistic chain to hinterland, and main tool is use the real-time information sharing about ETA, ATA, ETD, and ATD, and share this information with inland terminals, carriers, and other stakeholders, and can help them to plan earlier and track cargo in real time. It can improve logistic efficiency and reduce the costs. Also can enable better transport planning. However, this only works when clear rules and agreements are in place between all parties. And the final level, level 4, is connecting ports in the global logistic chain. Port of Rotterdam was to connect the entire logistic system globally and improve overall efficiency. And by some way like coordinate from planning to delivery. And their goal is to reduce reducing ships' unnecessary waiting time and emissions. And this model is the goal is to become more safety and more efficiency and sustainability. And now I'm going to talk about some technical skill is already used in Port of Rotterdam. The first one is the IoT integration. And the IoT integrations is support all of these digital method is support to make a digital twin. And the Rotterdam Port has developed a digital twin, which is a 42-kilometer virtual replica of the physical port. And it uses an extensive IoT network to collect real-time data on water levels, tides, currents, wind speed, and the visibility to help the ship owners can make a right and immediate decision, and also can allow the port to optimize berthing times and prepare for autonomous shipping by 2030. The next one is about shore power infrastructure. Port of Rotterdam has developed a new berth. The name is Maasvlakte 2, and it can handle around 27 million TEUs per year. So it's a very big terminal, and this terminal is totally implements the offshore infrastructure, so can be more safety, more sustainability, more efficiency, and combined with some the terminal have some automated facility and large-scale handling equipment, and also use IoT and big data analytics, this kind of digital skill. And the final is the eels and dolphins. This system integrates smart wharf with digital views. They are equipped with some IoT sensors. By using real-time positioning, the platform tracks exactly where a vessel is and charges fees based on the actual time spent at the berth. It can calculate by the sensors, and it also can enable self-loading and unloading in the rough weather, and supports ship-to-ship transfer, and can also be used for maintenance and bunkering. And this is the port vision about 2050. Its main goal is resilient and green infrastructure. And they have the 4-part plan. The first part is about energy transition. The Port of Rotterdam wants to be a hydrogen hub. It is shifting from fossil fuels to become Europe's leading green energy hub, and build some integrated hydrogen value chain and use carbon capture and storage way. And the second one is secure economy and smart industrial. The port is transforming into a strategy base for material recovery and regeneration, and combined with some industrial symbiosis and waste to value. And the third part is about digitalization, which is mentioned just before. The digital twin is the main goal to build, and digital technology will become the brain behind all port operations. So you have to use some autonomous shipping and smart logistics chain to improve the port's efficiency. And the last one is the agility and resilience. No matter it's now or future, they will facing a lot of global geopolitics shifts. the port is prioritizing resilience to safeguard its future. And so they have to improve their energy and supply security, cybersecurity, and also the flexible transport. And section 2, I'm going to analyze the port operation problem, and Lily will going to analyze the level force problem. So the port operation problem, I just choose the 5 examples. The first one is data interoperability and reliability issues. The data silos cause discrepancies in the digital twin. The lack of standardized data between ship and the port damage automated scheduling. We're forcing a continued reliance on manual intervention. And the second problem is the high complexity of dynamic environments, such as the weather, current, and traffic. It is hard to model, and due to the IoT latence in extreme conditions, fully autonomous shipping remains in trial stages, cause systems struggling with complex real-time operational demands. And the third problem is about congestion and the scaling bottlenecks. In 2025, because the scheduling lags during the alliance ships lead to the landside congestion. Without the agility to handle peak capacity, rising dwell times threaten to negative the efficiency benefits of automation. And the fourth is digital airspace management. Current unmanned traffic management systems struggle to coordinate mixed unmanned and manned traffic. These technical gaps increase collision risks and safety concerns. And the last one is about cybersecurity and resilience pressure. The port rely on the digital transformation rely on cloud and the edge computing expands the attack surface. It will also increase the maintenance costs. It is the problem about the port operation side, and my part is finished here, and let me show the video.
Thank you, Mira. My name is Lilis, and I will continue our presentation with the labor force. Because in Rotterdam now is facing 3 labor-related challenges. The first one is a short hint about the digital data and about the integrated operational skill. The second one is difficulties in shifting from manual process to share the digital workflows. And the third one is the need to redesign the job roles as the port operational become increasingly automated. What is it? In the detail, the shortage of the digital data and integrated operational skill. Because now, the port increasingly relies on the digital system, the real-time data, and the automatic planning. But it requires the workers with a skill data analyzing, with the data platform use, and they also need to the system coordination and automatic logistics. However, many employees now, they were originally trained for the traditional operational roles and not technology-driven port activities. So that's why the port now faces a skill gap that slows the adoption and the effectiveness of smart port technology. With the difficulties in the shifting from manual processes to shared digital workflows, the port operation have long depended on the manual communication and the paper-based documents, emails, and fragmented coordination. But smart port development, it requires shared digital platform. They need to standardize data, exchange, and integrate workflows. However, many stakeholders now, they are familiar, they still use a different system, different procedures, and different data interpretations. So, moreover, they need to, nowadays, their resistance to change. They don't want to change. They still have the inconsistent data input and weak connecting make digital implementation slower and less effective. And the last one, the need to redesign job roles at the port operational become more automatic. As in the past, many employees they are familiar with the manual processing. But now, as automation expands, the port jobs are changing in the nature rather than disappear completely. And workers are increasingly expected to monitor automated systems, analyze real-time data, and coordinate across operations. So, the job roles are shifting from the manual task execution to the supervision, to coordination, and system management. So this requires not only retraining, but also broader organization changes in the job design and performance expectation. Now we jump into the section 3, review of Rotterdam Port's current smart port policy. In this section, we divide it into two parts. With the first one is the current smart port policy, and the second one we will analyze is the effectiveness. Rotterdam now they has moved from the digital ambition to a large-scale implementation of smart port. Rotterdam's strength lies in building an integrated ecosystem rather than using the digital tool. I also have a key alternative include the port space PCS. They use Next Logic, also have a port exchange, security chain, CLAN connectivity, and cyber resilience program. So these methods jointly improve data sharing, operational coordination, logistics security, and infrastructure efficiency. We will focus on the six tools. The first one is PortPay. PortPay is the supplier. The port community system. It is a shared digital backbone for information exchange, documentation, and chain coordinate. With the port core optimization and a port exchange, it will improve and standardize information, operational, and administrative data across the vessel core process. With the Next Logic, it will integrate planning for inland container shipping and terminal capacity coordination. And the skill chains, Rotterdam replaces vulnerable PIN-based container release with the authorized closed chain model. And with the smart infrastructure and digital team, they use IoT sensors and access management and digital team for keywords, waterways, and logistics infrastructure. With the human capital, from cradle to key, smart ports and port energy alternatives to develop, train, and reskill the port workforce. So with this, Rotterdam not try to control all things. They don't need to do that. Instead, they build the shared digital infrastructure and coordinates with the wider ecosystem. It helps them to allowing different partners to innovate, and deliver smart port solutions together. Now we will analyze the effectiveness with the PCS. It is almost effective as digital backbone, and now it's a standardized data team, documentation, and chain coordinates among multi-stakeholders. It also provides the foundation for the other smart port solution. So it is the key market. It's currently connecting more than 6,000 companies and 50,000 users. The port base also states that over 7,000 organizations work smarter through its platform. Because we cannot find out clearly the detailed information on the Rotterdam website, we just got the information from the port-based reports. So in the conclusion, the highly effectiveness as enabling infrastructure, but it does not directly reduce time in the same way as other tools, but it serves as the shared digital platform that allows other smart port policy to operate at scale. With the port core, it provides a clear evidence of reducing waiting time during vessel call. And the core value of this one is the improving and synchronizing nautical, operational, and administrative data among shipping lines, terminals, and agents. And the key metrics is have to achieve at 20% of saving in waiting time. And it is also have a conclusion with the port core optimization that operationally effectiveness. Although the published evidence is still based mainly on the pilot result, but it will widely publish its annual KPI dashboard. With the next flowsheet, this is one of the Rotterdam's most measurable smart policies. It's a Rotterdam uses sensor and real data to monitor infrastructure. It addresses a major bottleneck in the inland container shipping by improving coordination between the large operational terminals and depot. It in part is visible in time-saving ecosystem-wide adoption. The participating vessels spend up to 20% less time in the port, and the system handles more than 1 million containers moved in 2023. And by early 2024, almost 2/3 of Rotterdam inland shipping volume was already under integrated planning. With the next logic, it's very effective in improving efficiency, planning, reliability, and key crane utilization. However, the implementation is not yet complete. It just as still covers only about 2/3 of inland shipping volume. With the skill chain, the more successful policy in the digital resilience and logistic chain security. Now its main strength is replacing false sensitive PIN. They use the container release with the authorized closed chain release model through port base. By September 2024, 500,000 containers has already been handled through skill change. And by March 2025, this increased more than 1.1 million important containers. Around 2,000 shippers for water and more than 1,000 inland operational have adapted their processes to join the system. So this is the highly effective and scalable. And it shows that Rotterdam is not only become more digital, but also the more skilled in its digital operations. With the smart infrastructure and digital twin, this policy is the most effective in asset management, predictive maintenance, and reducing the disruption. Rotterdam use the sensor and real-time data to monitor infrastructure coordination, support timeline inspection, and extend access lifespan. With this one, the port authority management more than 12,500 hectares and around 89 kilometers of key gorge. Its dredging account for an average of 10% of terminal availability. With this smart infrastructure and digital twin, strategy effective, and especially for long-term infrastructure efficiency, because to do this, they have to invest a lot of money. So it's especially for long-term infrastructure efficiency. We cannot consider it in the short term. However, the public performance indicators are still limited, and so this policy is stronger in capability building than in the short-term measurable KPIs. With the human, it be viewed as a long-term capacity building rather than a short-term measurable output. The Rotterdam recognized major labor challenge and has responded through the initiatives such as from key grants to key smart port and port energy. To do that, by doing that, they have around 182,000 people work in the port ecosystem every day. And by 2030, the port is expected to need more than 1,000 additional employees. And the Port of Energy project, Rotterdam, they run from 2023 to 2027, and they may receive up to 5.8 million euro from the Europe Fund. So, this policy, this human capital is important, but it is harder to measure immediately. These policies are essential for supporting digitalization, automation, and energy transition, but their results are currently more visible in the workforce, investment, and labor demand in short-term productivity KPIs. So let's take a look. We'll take a shot for our effectiveness. With the next flows, which is spent up 20% less time in the port. With the port Yi-Chih, the pilot results show that 20% saving in the waiting time. With the skill chain, the more than 1.1 million import container handled in 2022. Around 2,000 shipper forwarder and plus more than 1,000 inland operational adapt their processing. With the smart infrastructure, they access efficiency across 12,500 hectares and 89 kilometers of quay. With the human capital policy, they have 182,000 people already working in the port ecosystem, and now they predicted that they need 10,000 additional workers needed by 2030. So in the conclusion, the Rotterdam smart port policies are already delivering. The strongest outcomes are visible in the time reduction, planning integration, and logistics chain security. However, the port is still face ecosystem-wide scaling rather than the full completion. meaning the strategy is clearly effective, but still expanded in depth and coverage. That is all our presentation. Thank you for your attention.